Welcome back. We'll now discuss the further continuation part of the chemical bonding. Just to revise, in the last class we have seen what is chemical bonding, the definition, and in that what are the things which are involved in the chemical bonding. That those are atoms and they form molecules. So there are different types of chemical bondings. We have seen example of two. The chemical bond can happen, which is that the attractive force. Chemical bond, as we have discussed in the previous video, chemical bond is the attractive force between two or more particular atoms, either same or different. They can be interatomic, that is between two atoms, or it can be between two molecules. We shall see this intermolecular in the later stages. In the interatomic, we have seen two major type of bonds, that is ionic and covalent. Ionic is also known as electrovalent. And just to summarize the ionic bond, it is the transfer of electron from a cation to the anion. It happens between a metal and a non-metal system. It is non-directional, and in solid states, these ionic bond systems are non-conductive, but in the Molten states, they are conductive in nature. And we have seen covalent bond. Next, we have seen covalent bond. The other what you have seen, the coordinate and other things we shall discuss in the later stages. The covalent bond is the mutual sharing of electron, and it generally happens between the non-metal atoms, and it is directional in nature. So the covalent bond can be either polar or non-polar. When covalent bond happens between the two similar atoms, for example, we have seen a covalent bond between O2 or a covalent bond between N2. These are called as non-polar, and the covalent bond happens between two dissimilar atoms with different electronegativities. They are called as polar covalent bonds. We will discuss the polarity when we are discussing dipole moment, and also there only we will discuss the concept of electronegativity. So till now we have seen what is bond, what are the different types, that is intermolecular and interatomic, and in the interatomic bond two major types, covalent and electrovalent, are also known as ionic bonds. So now we will see one important property known as Lewis dot structures. What are Lewis dot structures? These are the ones which given by very famous chemist G.N. Lewis. He gave a way to write the electron configuration where to represent the formation of bond. For example, oxygen has 6 valence electrons. We have shown here 6, and these are 1, 2, 3, 4, 5, 6 valence electrons. And similar way, nitrogen has 5. And how an O2 molecule is formed? We have seen this in the previous class. That is 6 from here, 6 from here, and now a bond is formed here. 2 electron for each bond. So hence we have a double bond. This is Lewis structure. Lewis structure is nothing but arrangement of electrons around the nucleus. We are showing how the electrons are arranged around the nucleus. 1, 2, 3, 4, 5, 6. For example, it is the Lewis structure around oxygen. And Lewis structure generally we represent molecules. That is another oxygen. 1, 2, 3, 4. I will show here this one. Now this is the Lewis structure of O2 molecule, which is nothing equivalent to or O2, which I have shown here. Similar way, nitrogen triple bond, we can show the Lewis structure like this. One important thing is the Lewis structure is you have to write how many outermost electrons are present. For example, in nitrogen, oxygen 6, nitrogen 5, like that. First you have to write the outermost electrons. Then you have to see to satisfy its outermost orbital, that is to get 8 electrons, how many more are needed. For example, you needed 3 electrons. Either you can form a triple bond for the nitrogen, or you can form 3 single bonds between 3 hydrogens, 1, 2, and 3. Now you have 2 plus 2 plus 2 plus 2, that is 2, 4, 6, 8 electrons. So you have to represent all the 8 electrons. I hope the concept of Lewis structure and how to write the Lewis structure is clear by now. You have to see first step about writing Lewis structure is see what is the atomic number. Then you have to see how many electrons are present in the outermost orbital by checking its electronic configuration. After getting it, you have to write the atom, and you have to dot the electrons present. For example, you have 5 electrons in the outermost, dot it. Then you see how many electrons are needed to form its octet, fulfill its octet. And given the structure, for example, if the structure is given is N2, you can write a triple bond Lewis structure. That is, you can write like this. Or the structure given is NH3, you can form 3 single bonds like this. So this is what about Lewis structure. Next we will see, we have seen different bonds now. We have seen ionic bond, we have seen covalent bond, and we have seen how to write those bonds. So let's see different properties of bonds. First, let's see bond length. We have seen a bond is formed between 2 atoms like this, and the distance between the nuclei. This is the nucleus, it's the atom A, let's take, this is the atom B, and there is a distance between these 2 nucleus. This distance, the half of its distance is known as bond, this total distance is known as bond length. That is an atom here, an atom here. The distance between the nuclei is known as bond length. This is the total length of the bond, but when you take half of it, like here or here, it may not be exactly half. This region is the radius of A and this region is the radius of B, which we have seen in the atomic radius chapter. In the first unit, we have seen atomic radius. So a bond length is nothing but atomic radius of A and atomic radius of B. That is, if we have a compound like O2, oxygen, 2 oxygen molecules are forming a bond. The distance is, for example, let's take this is O1, oxygen 1, this is oxygen 2. Distance is, the bond length is the distance between the nuclei of first oxygen to the distance between and to the second oxygen. This distance is the bond length. It is nothing but atomic radius of O1 plus atomic radius of O2. Hence we can write bond length is nothing but, in just simple terms, bond length is nothing but atomic radius of atom atom A with and also atomic radius of atom B. That is, it's the sum of the 2 atomic radii, and also it is the distance between 2 nuclei which are taking part in the bond. This is the definition of bond length. It's one important property of a bond, and a bond has an angle. If there is a 2 atoms like HCl or HOH, sorry, for example, else I can write O2. These kind of these don't have any particular bond angle because it will be along the axis. Hence, we can say the bond angle is 0 or 180 degree. It will be similar. But when we take a bent atoms, like for example, we are taking an example of H2O. Here will be the oxygen, here will be the hydrogen, and here will be the hydrogen. Or we can take example of ammonia. That is NH, H, and H. In this case, there will be a bond. There will be an angle between these 3 atoms. This angle is known as bond angle. You can write it as theta. Here also we can see 3. See, we need 3 atoms, 1, 2, and 3 atoms to get a bond angle. And here also we can see a bond angle. Bond angle is the angle formed when 2 bonds are formed. That is the angle between the 2 bonds. We have OH bond here and OH bond here. In what angle these OH bonds are present? This is known as bond angle, and we will discuss about the hybridization concept. This bond angle property will become extremely important because it strongly depends on the concept of hybridization. We shall discuss that in the later stages. First, you now keep it in mind, a bond has a length which is nothing but the distance between the 2 participating nuclei, that is 2 participating nuclei, and bond angle, which is the angle formed between the 2 bonds which are attached to a single atom. Here we have the atom X, or here we have an atom O. 2 bonds are formed, one here, one here. Similar way, here 3 bonds. These 2 are 1 bond angle, these 2 1 bond angle. We can have this particular bond angle also. And another property is bond enthalpy. Bond enthalpy is nothing but if there is a bond like O2, or we can take N2, or we can take CH4. These are molecules now. Now, if we put some energy, we can break this bond. There is a bond like this, O double bond O. We have to break this bond. And to break that bond, we have to supply some energy. The energy which is needed to break the bond is known as bond enthalpy. Higher the bond enthalpy, higher will be the bond strength. Strength of the bond will be higher. For example, delta H for breaking oxygen bond is 498 kilojoule, which shows that the bond the bond is quite stronger. And the another important parameter is bond order, which is nothing but what is the type of bond present. Is it a single bond or double bond or a triple bond? We know to form a bond we need 2 electrons. If only 2 electrons are involved in a bond, it is a single bond. Then if 2 electrons and 4 electrons are shared, Like in a case of oxygen, 4 electrons are shared in between an atom, in between two atoms, then it is a double bond. If 3 electrons are shared, 3 pairs of electron or 6 electrons, 1 pair, 2 pair, 3 pair between like nitrogen, we can see there are 3 bonds are formed, 2 for each, 1 for each electron pair. So now to summarize, we have seen 4 different important properties of a bond. Bond has a length and it has the angle formed due to the 2 bonds which are inclined to each other. Like for example, there is a bond here, there is a bond here, they are inclined, and we can see there is a central atom, a bond is inclined like this. This angle is known as bond angle. And a bond has an enthalpy, because any bond is formed will be a stable system. Bond, first we have seen this one, we have discussed this. A bond is formed to make a stable system. Since it is a stable, we need to put energy to break that stability. That energy we are applying is known as bond enthalpy. Stronger the bond, higher will be the bond enthalpy. Stronger the bond, higher will be the bond enthalpy. And finally, the bond order, which is nothing but what type of bond is present. Either it is a single or a double or a triple bond. Single bond will be formed when just 2 electrons are shared between 2 atoms. When 4 electrons are shared, we'll have a double bond. When 6 electrons or 3 pairs of electrons are shared, we have triple bond. So till now we have seen what is a chemical bond, types, 2 major, ionic and covalent, and how to represent them using Lewis structure, and some of the important properties of a bond. From next onwards, we will discuss about dipole moment, and we'll go into some of the concepts in the bonding, some of the different concepts which will be little advanced than the regular bonding concept, because this we'll see some of the advanced concepts in the bonding like VSEPR theory and valence band theory, etc. So I hope this the concept is clear to you. We'll see in the next video. Thank you.